I think we need to form the Guild of Optimus Talking Heads, or
Okay.
Goths. This is it. This is the last Optimus video we are going to do until there's an Optimus in Atlanta and Central Florida. Okay, not or. We're going and. We're boycotting right now. Okay, this is it. Until we get one, we are not doing any more Optimi videos.
Hey y'all, it's Dr. Know-It-All. Guess who I am with again? It is Dr. Scott Walter, and apparently we are going to do our last Optimus video. We're holding Optimus videos hostage until we get some Optimi samples in the Atlanta area and somewhere in the Central Florida area, Orlando, Tampa, I don't know, Ormond Beach, Daytona
Kennedy,
Beach, whatever, somewhere in there.
Sarasota, yeah. Just not Miami. I don't want to have to drive all the way down there. So
exactly.
Since they haven't come to Florida at this point, I'm putting more conditions in it. It's got to be Central Florida.
There we go.
So yes, so we formed, the Guild of Optimus Talking Heads, and or Goths.
Right.
And we're going to go on strike after this. So this is a strike action right now.
Well, we just want to get behind everybody else who's going on strike these days.
Yeah, so this is the problem, is we're going to do a video about the Optimus bots or Optikins that are showing up in all the Tesla showrooms.
Right.
And we're like the only ones that don't have it anywhere nearby.
Yeah.
So
everybody's been saying, like, why don't you guys?
They got 2 in the LA area. Come on.
I know. I'm like, everyone's saying, like, why don't you guys just do a video of ones that are in your area? And we're like, there is none in our area.
Yeah.
But before we start this, I'm going to share something with a janitorial robot developed by Somatic Cleans the Toilet by itself, just because this is fun. And of course, Scott, had to, get another dig at Roomba in there and say, like, oh, we have an actual real robot here as opposed to a fake robot. So I'm going to play this. I've got the sound off, so it's just music anyway. But you can see this cute little guy with some sort of, like, I guess, clean and dirty water tank on it. But it comes in here, cleans the toilet. And I love the little pseudopod hand thing that comes out and, like, pushes the toilet seat up and everything. It's very adorable. But the one thing I noticed, it cleans the floor really well. It does all this stuff. It doesn't actually clean the toilet bowl, which I was like, wait a second, what's the point of this thing?
It doesn't use a brush. It looks like it probably sprays something on there, but doesn't do anything more.
Yeah. And so a little bit odd. I mean, it does the floor and it does the seat, but it doesn't do the bowl itself. So I don't know exactly that. But anyway, it's pretty cool. And if people want to stick around for the end, Scott was regaling me of stories of the KOA campsite in the 1970s that his family ran, and literal poop storms. So stick around for that if you want to. I'll put it after the end so that
now look right here. I think you'll see like a little foot come out.
Isn't that awesome?
Hold the door propped up. Yeah,
there's a little like it feels like a like a mollusk, like, how they have the pseudopods that they stick out and then they kind of drag themselves. It kind of looks like that, having that, but very cool articulated arm. I mean, it's got a lot of degrees of freedom on it. And can do very.
So that might be an example where didn't look at it close enough, but it's probably a 7-degree of freedom arm to give you kind of that extra degree of freedom that you need to be able to get up and around into things. And that's why you need that dexterity. Now, the one thing about it is that partly, let's say, I'm an expert on cleaning toilets because I did it, for 6 years, which we will find out at the end of this video. So I know a little bit about the processes going in there and it's required. And the other thing is, this looked awfully familiar because it would be almost 30 years. Over 30 years ago, almost 40 years ago, we did some simulations of a robot exactly like this.
That's
back in the 80s. And this was for Joe Engelberger. And Joe Engelberger is considered the father of robotics. He founded Unimation Robots, and basically, was the one that insisted that these be called robots. And so he sold that and was getting into another business, and he realized that service robots is where it was going to be. And so the last company he had was working on things like this. Part of it was like a lot of the mobile robots that you see in hospitals. They already started in the 80s, and that was something that he was doing, of coming up with robots that could help out in there. And other were thinking how they could do cleaning in hotels and everything else. So he was already thinking way ahead. The thing is, some of the technology wasn't quite there yet, but we did some simulations exactly like that with an arm going in and going on the toilet. And it turns out, when you go in and clean a toilet, you just don't do certain things. There are a checklist of items you're supposed to do and how you're supposed to do it. So when you clean the bowl, you're actually supposed to go in with a brush and go around a certain number of times. So the simulation we did it's like was based on one of those kind of scripts. So we had to show that the robot could go there and do exactly like lift the lid, go in, take a scrubber brush, go around and do everything else. And the bot looked remarkably like that. It had some sort of service area behind it with an arm in front, be able to go over and change different end of arm tooling. So it's not, let's say, a new idea, but maybe it's finally someone's been able to package it in a way. Because at that time, he realized that we didn't, we were still talking about like 8-bit microprocessors,
Right.
and whether you would be able to have the intelligence necessary for the robot to be able to kind of deal with all this stuff. So, I mean, sometimes you go in there and go, okay, this is just going to be a simple sanitation. And then others, it's like, oh my goodness, this is going to require a little bit of extra work.
Right.
And you didn't have the vision systems at that time that would be able to tell, yeah, this is going to be a big cleanup job, or we need to, like, rather than do the standard 3 times around the bowl, we got to maybe go 4 or 5. And so
Right.
he was thinking at that point that you would have some sort of connection to some mainframe where information would go back, and it would then
Oh,
figure out what was going on and send the information back. And this is like before we even have the internet or anything like that. So he's already like putting an architecture together that seemed remarkably close to what we're doing today.
right.
Yeah, so and yeah, I remember exactly us putting that thing because the hard part was after we did the simulation, getting it from one of those, flat screen CRTs, or not, curved CRTs,
Right.
and making a videotape out of it that was really sharp and everything else, and had a good time lapse, because in that time the simulation was like clunk, 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 and you wanted to get 24 frames a second, so you had to take one image at a time, and it literally was like, photographing it with a special hood
Right.
around it. It cost a lot of money.
Yeah.
And now it's just like we just do these screen grabs, we're done. We just take
Right.
it so much for granted. But it was, literally thousands of dollars when you were done with the simulation to be able to transfer it to a tape that would be of high enough quality that someone would be able to look at.
Right. Yeah, yeah. That was I remember that. That was a big challenge, was getting things off CRT. And plus it's the CRTs flickered and everything. So you'd have to do the exposures had to be relatively long, but if they were
Yeah,
too long, they would blossom. You'd get too much
yeah.
bloom on the image. And it was all analog. It
Oh
was
yeah,
just
yeah,
it
yeah. So
was
you had, I think we were
crazy.
using like a lion lamb system that would synchronize that. Once we get a frame that was kind of up there, we would get the exposure and there would be a hood around it. And you try to have it back. So you had kind of a zoom lens that would help flatten it out. So you
Yeah,
didn't see the
yeah, yeah,
curvature that was there. You
yeah.
try to cover it off, and you made the exposure a certain amount of time. And of course, there was like, I think it might have been like 35mm film, and you just advanced it one frame
Oh
and you
yeah,
took a picture.
yeah.
And then whoop, then you waited for the next one. And you'd have to run the whole thing like the whole weekend to be able to
Right.
get all the frames that you needed. And we weren't talking about fancy ray casting or anything like that. This was still using SGI machines that didn't have a lighting model at that time. So we were actually using our own lighting model, which
Right.
was not ray trace based, but was a very simple kind of thing, and
Yeah.
just the Z buffer.
Right.
So, okay. So it was good enough. You were
Wow.
able to get enough effects, but boy, was that costly, and was it tedious.
Yeah.
So yeah, half the quote was like, well, the cost to be able to just get it from the screen in a format that you can actually deliver and show to someone.
Right. Yeah, and I wow, that brings me back to the old days. I like that was where 3D animation started, was all that kind of stuff. It was crazy how complicated it was. So if anybody wants a history lesson, you should take one of my classes. I'll talk about
Yeah.
that. Or we could just do a video on that if people are interested. That would be really fun to talk about the old days of 3D animation and simulation and everything. So I guess we can turn from that to our amazing new robot, which is Optimus. And let me see get
Hmm.
this guy shared. It's always hard to find the exact
And of
screen.
course, the first thing everyone says is like, well, that's something that Optimus could do, and probably could. It's like there's no
Yeah.
reason why humanoid robots couldn't do a task like that.
Oh, absolutely. I mean, we're talking about this is exactly the kind of thing. But so
Yeah.
what we've got is, because we have a number of optimi, I guess that is the correct term
Mhm.
since it's Latin. Since we have a number of
Yes.
optimi out in the wild, we are getting better and better resolution images of this. And again, it's just sad that neither one of us has access to one of these things close by. So I should say, before I continue on, we should give credit. This is Keith Violet or Violet. I
Yeah.
don't know. But anyway, thank you so much for
But
posting.
probably Violette or something like that.
Violet Day. Yeah, yeah, yeah. So this is from Massachusetts. So
From
Massachusetts.
Natick, Mass. Yes, on Route 9. I know it well. I mean, it's like they're taunting me because I grew up in that area. That would have been like a 10-minute drive from where I
Yeah,
grew up.
yeah. And by the way,
And
I
I
was
have friends out there. It would have been easy.
I
Yep.
was born in Boston too. So, not
Yep. And then the next place is like Somerset Mall in Michigan, where I'm not at right now. I'm down here in Florida. So if I was up there, so Chris from Dirty Tesla was able to go up and get some pictures.
yeah,
But these are nice. And the thing we've been trying to figure out is, it's clear it's not a functional Optimus because, there's no
Yes.
wires, there's no batteries in like that. It's just sitting there. And basically it's like a mannequin. So we're just kind of calling it an Optikin. The question is whether it's made from the actual components that would go into a real Optimus or not.
Right.
And it's very hard to tell from pictures whether those are 3D printed parts or not. And so the first indications we had that maybe not, because a lot of the pictures that came in, like from Peterson, stuff like that, were fairly well detailed, but still a little bit grainy. You couldn't tell. They look pretty good. And we just sort of assumed it was, maybe made up of some of the originals. And Rob Ford took a look, and he thought, he wasn't able to touch it, that it looked pretty much like the real thing. And certainly if you compare it to the Optimus videos we have, they are faithful, geometrically, the proportions and everything are exactly what you'd expect to see. But it's really hard to tell. Is that a 3D printed part? Because it's very nice and smooth and everything else. But is it aluminum? It kind of looks like aluminum, but is it not aluminum? I don't know. The hardware looks like it's the real thing.
Well, but the thing that really starting to blow my mind is the organicness of like this arm shape. And then if we go back to the leg, you can see the same thing. And I mean, look at this.
Yes.
This is a
nice.
one piece. And that
beautiful.
looks injection molded. I mean,
it could be plastic, it could be, if it was aluminum, it could have been cast.
Right. No, but I mean, sorry, I should have said,
or it could be,
but like, but the same idea that they have.
Or could have been injection molding if you're doing that, or it could be 3D printed depending upon the volume and everything else that you have.
Right.
Now, Chris from Dirty Tesla, when he was at the Somerset Mall, he wasn't able to touch it either. He got some pretty good photos, but he was told by the staff that it was really light. It was very easy for them to put in. Now, the question is, it's only supposed to weigh about 125, 130 pounds anyways. And if you take out the actuators, the guts of the motors, the battery pack, and a lot of the other things, you can probably get it to be easily under 100 pounds, maybe 80. And is that considered light?
Yeah.
Now, when you go to Keith Violette, he in Natick, he's pretty sure it's 3D printed because that's what he does. He was able to identify it as nylon.
Yeah.
So he's pretty sure it's a really good mock-up, but it's a combination. So the first thing I wondered is, okay, it's a really nice 3D print job. And in many ways, the details are very good, but is everything 3D printed? Like, the hardware, meaning, the nuts and bolts, like that ring and everything else. And it's like, no, that's probably the real stuff.
Right.
So
if this is 3D printed, this is usually 3D printing is a little less shiny than this. This has a very high.
Yeah. And there may have been some treatment after the fact. See, I don't know how much is 3D printed and how much is not. So like the housings for the actuators, those might be 3D printed.
Yes.
And then the hardware to assemble everything might still be the real thing.
Right.
Because those are probably fairly easy to just, pick up, or that, Tesla may not be manufacturing, they may just be purchasing a lot of those items.
I think it's worth pointing out here too. There have been several people saying that there are actual actuators in here. I don't believe that that's the case.
I don't think there are.
I think these are just housings.
They're just the housings. Yeah. They would be just, so even if it was the actual housing, it's not. Now, there's a couple of things that we can sort of tell and why, whether they do or do not have it, that are rather interesting clues to what's going on. So I think if you go back to the shoulder.
Okay. Let's see. Yeah.
So one of the first jokes I put out there is that, the reason why this should never be in a mall is the first thing Optimus does is goes to the one of those kiosks that does body piercing. So we can see that little ring that's on there. And the question is that a pin that goes all the way through to lock the motor in place? And, the other thing was that something that was kind of put in, the 3D printing, was it in the original design or not? And it is in the original design. You can see in all the Optimus videos that placement of that hole is exactly where it is. And we'll take a look at the CAD data later. We'll see that hole doesn't actually go all the way through.
Really? That's interesting, because that's the standard kind of pin where it goes through and you have the ring.
Yeah, that's what it looks like. But at least according to and of course we can't tell if it goes all the way through, but down on, I think in the elbow or wrist area, there's also another motor. It's a different motor. It's a smaller motor, and its pin seems to go all the way through, because when you get shots in the front and back, you can see it's there. So it kind of locks everything into place.
Yeah.
Now, only the mall Optimus have those pins in place and that ring. and whether that's like for shipping or something like that, yeah, we can't quite see it from there, but that pin does go all the way through on the other side. But they're not wearing those things at all. So I'm not sure what the purpose is, especially if it only goes partially in. Now it could, I've never seen them use it for, but it could be it's a way to be able to help you with the routing of the cable. That your cable ties and everything can maybe get tied off on that or something like that. So that might be part of the purpose for that.
Okay.
Anchor points for that.
Right. It is really interesting that why those things are there. That's just, and clearly there's one on the arm, one on the upper arm, and then I think, is there one on the thigh also? I'm trying
I
to
didn't
remember.
see any down in the thigh because those motors are completely different.
Yeah.
So the leg, so we'd have to look in the pelvic
Another
area to
angle.
see something. And I didn't notice any around there, but could have escaped my eye.
And this, by the way, is Tesla Yoda. Unfortunately, do not have where this was taken, but I assume it's another mall, another
I think it's in
showroom.
Vancouver. That one.
Oh, was it?
So I mean, it's already left the country, and we still don't have them in
I'm
Florida.
I'm going to Vancouver in early September. So if that is there, I will find it.
Okay. So
I will get to see it live. Of course, we also got to see it live, like the AI day and stuff. So,
now the one thing is what you can try to do here is there are just some interesting things about design. When we talk about how faithful it is, look around. You see all those protrusions that are there where there's nothing going through it. I have no idea what the point of all those things are.
Also, I just want to point this out for 3D printing. Does that looks more like machining than printing? The lines.
It's so that's why I'd like to go in there, and when the Tesla staff is looking the other way, just go over with my finger and just go like that. Ding, and if it goes ding, then I'll know, oh, it's metal. Yeah. But if it doesn't, if you get a flat tongue, then you know it's plastic.
Okay. I'm gonna take a selfie stick with me and then accidentally swing it at like the thing. And whoops, sorry.
Yeah. Now if you look at if you look closer to the wrist,
yes.
I mean, if you look at that hardware, that looks like most of that there definitely looks like it's real hardware. And if you go up to the top, where the kind of that spherical bolt is right there, or where the spherical joint is now. Yeah, right there. I mean, all that to me looks like it is, probably the real deal. Whether that housing, the black housing that's there, that could be printed. And then they just have a metallic shaft that's going in there. The interesting to notice is that metallic shaft is not cylindrical, but you'll notice it's prismatic in shape.
Yes.
And that's to kind of lock it in its position so that there's no way that it's going to rotate about the, the
this
axis.
Actually, maybe the reason for these pins is because it's a demo model that doesn't have the actuators to hold it in place. So that may just be a lock.
It would go through and lock it
90 degrees. Otherwise it would just flop down from gravity.
Yeah. So you probably need something like that to lock it in. There doesn't seem anything locking for those black linear actuators, which, you'd want something also to be able to, because that elbow, the position of that elbow is determined by that black actuator in the back.
Yes.
And whether it goes in. And of course it could be that, well, I mean, in theory, it should be able to go all the way up there, but they must have something in there that's kind of stopping the movement of it.
Right.
Yeah.
But that could very easily be something like this. That is,
that we're not seeing. And
that there's a shaft that goes up and they just punched a hole through the shaft and they're sticking that in there to hold it, so that when it comes disassembled or floppy or whatever, and then when they put it up, they put the pins in. Now
again, all this looks very smooth and very nice. We can see more hardware up there where you have these long pins that are kind of holding the actuator together, because it appears like the actuator is made up of 3 parts. We can see the flange on the right side that goes into the black housing in the back, which is just a cover. I mean, that's just there to, I think, to cover a lot of the cables that are moving around there. And then you have the central cylindrical core. That's also another piece. And then you have a cap on the top there. That also, I think a lot of the armature and everything else kind of fits in there. So there's 3 parts that have to come together to put that together. So it's kind of faithfully recreated that way, because we can see it's 3 parts and not like, one solid part, which you could print it out that way and not go to the bother of having to assemble it. Now, the shininess of this material looks a little bit different than what we've looked in some of the videos.
Yes.
So, that's why it looks a little bit dull, whereas the actual aluminum one seemed a bit shinier. So that might be why some people say, it's definitely, probably nylon or something else. Now, nylon is pretty tough for a lot of these applications. So, I mean, you can thread it and everything else to at least test it out for your assembly purposes.
Right.
Now, obviously, it's not going to be tough enough for the real thing. Otherwise, that's what they would make it out of.
Right.
But it's certainly good enough for being able to put something like this together and test it out. And again, when we look at the other Optimi out there, it's perfect to the T, you know, and a lot of those details that I've always wondered why they're there. So you see those flanges kind of sticking out where the motors mount together. Yeah, I mean, so you get these little wings that are kind of sitting out there. It's like, you know, do you really need them? It's like, well, you kind of need them because that motor is identical to the motor that's attached to it. And if you look at it down in the lower right corner, you can see that that's used to kind of attach itself to the back there. And I'm like, geez, do you really need to have that sticking out? Because it seems like there's another bolt hole there that you could use to attach to that black housing. So, you know, see, it seems to me like it's designed to be like a Swiss Army knife, that there's all these different configurations we can put it together. So the problem is when it comes together, you have a lot of things that are, you know, kind of like the, you know, the appendix, you know, it's something that's not needed anymore. But because you only want to have, you know, that one SKU for them, you have to deal with the fact that you have all these extra bits that don't need to be there, that to me are snagging hazards and everything else.
Right. Well, actually, I wanted to ask you about that anyway. What is the cobot status of this? Because I mean, look at this. This is clearly not.
Oh, it's gonna be covered up. And this is what I'm wondering is that you see that motor that's there. Now we can go through all the different actuators. That motor that's there, that's the only use of that motor. Now up at the shoulder, there's three motors up there that are
one
identical.
in the back here.
No.
These guys.
The one that rotates it, not the black motor, the silver motor with a ring.
Yeah.
That's the motor for taking your arm and being able to roll it this way. That, you know, that's the only use of that motor. It doesn't show up on the legs, doesn't show up anywhere else. So the motor's up on the shoulder. There's 3 in the shoulder, and then there's 3 down the pelvic area. So there's actually like 9 in use throughout the whole thing. So that's the most popular one. So that's the one that, you know, you think about it, it's like, oh, we've got all these different configurations and how it has to go together. We've got to design it so that it just is able to snap together, you know, left to right or right to left, or however you want it to go together on all these different angles. But if you look down at that elbow again, it's like, well, wait a minute, what's the point of all those things if that's the only place it shows up and they're not even used and they don't even line up? So I think there's some other pictures we'll see of them where maybe not here, but on one of the others, where you'll have like 2 holes sitting up in the air somewhere. And 2 holes somewhere else. Like, well, wait a minute. Shouldn't they just like rotate around and snap in? And they don't. So I'm not sure why it's like that. And it is designed that way. When we go to the actual design specs of it, they showed it. They showed it being that way.
Okay. I guess we're at videos at this point. So that was it is. Let's see.
Yeah, go ahead and do the videos, because a lot of times
we'll
be able to see some of the things I'm talking about.
This is Plano. And I hesitate to go to full
This is the
screen
very first one. Yep.
Yeah. But you can see how all these guys attach to each other, how they work. Oh, this is actually interesting because his arm is extended here.
Yes, exactly. It's a different position.
Right.
And we'll see the elbow. So it's out there very, very differently.
Right.
And you'll see there's like covering on the kneecaps, which we don't actually see in the wild, and the feet are different of what's in the wild.
Yes. But the
of course, it could be that it's just it's a cover they're putting on top of it. It might be that the feet aren't actually any different. It's just a slightly different cover.
So still flat feet, but just with a different cover.
Yep.
Yeah. Okay.
And that looks pretty good. Okay, maybe can we get a good pause or close up in there? Okay, pause right there. Yeah. Just go back, because you can see the pin joint coming all the way through if you look on either side of it.
Okay. Are you looking up at the top? So
looking on the right side there. So that's the back end. So you can see it's clearly coming through there and locking that in place.
Okay.
So it's locking the movement of that, but then they did obviously something a little bit different with the elbow.
Oh yeah, you can see this really clearly right here.
Yep. It goes right through.
Clearly. But I think that's because there isn't an actual motor in there, so it's just something to lock it in place.
There's no actuator. Yep. There's not.
I always get a little loose on the actuator versus motor thing, but yes, actuator. So yep, and then standard on the back. But he's got a plate, and he's also got his giant stop button down the back of it.
That's the stop button that you definitely want to have. Yes.
So yeah, so let's talk a little bit about cobot status. So cobot, for those who don't know, collaborative robot, right? It just means it's designed to be around humans and not
Yes.
be dangerous. Something like down at the bottom here where this elbow is clearly that little boy could stick his hand in there and
And when
feel
it moves,
feasibly it could move
yes,
and pinch his hand.
pinch his hand. Yep.
Yeah.
Break
So,
your finger off, something like that. So,
yeah.
so there's a lot of things like that that are exposed, that you would have to be very careful that when it starts working near humans. So what that might mean is that if this is actually in the factory floor, is that you would have safety caging around Optimus to make sure humans don't enter the Optimus cell when Optimus is working,
Right.
which kind of defeats the whole purpose.
Yeah.
So at some point, there's a lot of things in there that have to be fixed. The other thing, everyone keeps on thinking that, Optimus being doing valet parking.
Right.
And I said, well, there's a couple reasons it can't, and that is it just can't crouch to get into the car in the first place because it can't move its head, doesn't have enough, flexibility in its torso. But I will just say this: Optimus is one butt you don't want in your seat. Just look at the buttocks back. I mean, you when it comes back, you're going to be complaining, what happened to my seats? They're all torn up. So,
or it'll just have like really big indentations in it.
Oh yeah. Yeah, exactly.
Yeah. I mean, look at that. That is a hard,
you don't want that. No, no way. You don't want any of that in your car seat.
Yeah.
So if you don't want that sitting in your car seat, you definitely don't want humans around there where they can poke their fingers in there.
Right.
So they're going to require some sort of covering. And that's why I wonder if some of those other things that are sticking out, they must have a purpose. They were designed in there for a reason.
Yeah.
But the purpose is really not clear.
Right.
It's not clear at all to me.
But one of the purposes could be that there will be some sort of plastic or cloth sort of casing.
There's going to have to be something around there
on the outside. Yeah. So I mean, what we're seeing right now would certainly be usable in a factory, but you would have to sequester it from humans.
Yes. Basically, what you would probably end up doing is take the safety fencing that is blocking the humans from the other robots and maybe moving it back. But since the idea is that you need the humans to be able to go in there in case Optimus fails, you can't really do that. So those safety precautions are going to have to remain in place, and you may have to do something else. And there's some simple ways. You don't actually have to put in a physical barrier. There are ways where, what they do in cobotic standards, a lot of times you'll have some sensors that we're able to tell when someone enters the cell, and that's it. And then it just stops.
Right.
Stops its activity then.
Gotcha. So I mean, so realistically speaking, we could be looking at something like this would actually be used on the factory floor in the near future without a covering. But certainly before it goes out into the more general population, it's going to have some sort of.
Its edges are going to get smoothed off.
Yeah.
So now it is rather interesting what some of the things that Elon tweeted about Optimus the other day, and one of it was that like the hardware is harder than you think, kind of thing.
Yes.
That so again, kind of underscoring that the motors and everything else has certain kind of requirements. And again, those requirements can be a bit conflicting because, well, you want to have, a nice tight package in there, everything works. At the same time, you have to make sure it's not exposed and going to cause harm to either your environment. Yeah, stop right there. I mean, just look at that thing sticking out there.
Yeah.
If you just go back a little bit. Yeah, just
need to kill the audio here a little.
Yeah, go back. I mean, just look. I mean, it's like, come on, what is that? And
are you talking about this guy right here?
Yeah. And then you see, if you look at it, that you have two parts that kind of mate together right in the middle of that, and you get these holes that are out there. So wait a minute, there are those two holes there, and then if you like go around to the other side of the top part, you'll see there's also like another set of two holes that I wonder, like, why don't those things line up?
Right.
Yeah. Since that's what's attaching that actuator onto the elbow. So that whole thing just looks strange to me, and they designed it for a reason. I have no idea what the reason is.
Well, but if the ultimate goal is to put some sort of plastic casing over the outside, then it could just be it's just there. It seems like it's kind of over-engineered though, because it's really thick. For putting plastic on, you could get away with, this wouldn't have to be nearly that, like that thick of that amount of aluminum or whatever.
None of that really quite makes sense. It seems like there's probably some other way of putting it around there. But and again, that thing is sticking out, which means you have to put some sort of cushioning or protection around that in the first place. So
Right.
why over engineer it? There's got to be another way to snap things in.
Yeah. So, and again, if people don't remember, the original Optimus, when it was introduced, of course, was a human dancing, but the images that they had were white plastic. So the
Yes.
head area looks the same up here. This all looks basically like the Optimi that we had originally, but the
Hmm.
rest of the whole thing was a white plastic. Now it looks like what they're doing is they're moving more towards an aluminum, but they are definitely going to need to cover a lot of this stuff up
Right,
before
right. So
they're going to
there's
be
a lot of plastic parts, some which we expect will be 3D printed at first and eventually
right,
probably injection molded. And it may be that some of the components on there really are the plastic parts they plan on using in the actual Optimus,
right,
and the others are just 3D printed out now to get these mall displays. So what that means, it kind of throws cold water on our speculation that these are like the early runs that they're just kind of getting out there for us to see. And it still could be that they're using these plastic parts to inform them on how everything should be constructed, what the order of assembly is going to be. They may even be testing it out there, but it's not quite, let's say, the uh, I guess you can say the indicator that I was going to be having when they're getting ready to really ramp up if we start seeing a lot of them.
right, right. Yeah, yeah. The one thing that I'm also noticing is I think we've seen 4 different Optimi here in different locations. As far as I can tell, they look very, very similar, if not
Yeah,
identical.
I
So,
don't I don't see any differences between, and
right,
disappointingly, I don't even see like a label or serial number or a tattoo
yeah,
or anything on that you'd be able
yeah.
to tell them apart.
Probably on
So
the bottom of its foot.
yeah. There's probably some. There's no fingerprinting or anything like that. So the
Right.
only difference is sort of like what you pointed out is that the arm is in a different position,
Yeah.
so you can probably cant it to wherever you want it to be.
Right. Yeah, they may have just, again, some holes
Yeah,
or something like that
yeah.
in there.
Now,
So, and the
if you want
feet,
to,
the feet look flat, but they look like because it looks like there's a black at the bottom.
yep,
So,
yeah,
because
that's. Hmm.
the ones that we've seen in action, of course, have had very flat feet, but
Right.
now it looks like what they've done is they've created something that looks a little bit nicer and more like a human foot, but is ultimately still the
Yeah.
same thing.
And you can see that, the knee pad that's there. So it looks like it has a nice kneecap. So
Yeah,
that's nice and smooth. And I want you to look at that because I got a couple of slides we can go through quickly
right
to sort of
here.
see,
That's what you're talking
now that,
about right there? Yeah,
yeah. So now we'll kind of see it and maybe we can kind of contrast it. So if you look at a lot of the detail that's in some of these things, it's going to
right.
also show up pretty quick and easy.
Yeah.
And when we
Do
start
you want me
looking
to
at
stop
everything
sharing
else.
so you can
Yeah.
just
Yeah.
while you're looking at actuators here, Elon specifically, he said it's a lot harder to do than he thought and than they thought or designing it. But specifically the actuators sound like they are being a
Yeah,
real
that's the big
pain
thing
in
is that you
the
need to
ass. So,
have
yeah,
the right set of actuators. So again, this actuator here, they only use well, 2 of them, one on each side.
right,
So in a sense, really just one purpose. And it's this thing here that I'm sort of seeing is like, wow, that's a rather interesting kind of protrusion. And we see shows up in the design. And then over here, we are seeing these other parts here that also show up in these designs everywhere else. What's going back? Yeah, what was going back here and there and stuff like that. So that's all there, and we get an idea of what's going on, and we can see what we see here. We're actually seeing out there
right.
along here, all those mounting plates, everything else. Now,
But if
this
you
is
go
where the
back,
motors
if you go
go.
back 1 second, it is
Yep.
also
Mhm.
interesting that the smaller, are those the smaller ones? No, those are actually 539. Just the larger ones have that black sort of maybe plastic housing around the outside of them. I don't know.
It seems to be different material. Oh yeah,
Yeah,
down here. So yeah, the
yeah,
linear ones are using a different kind of housing.
right.
Um, Yeah, it's hard to see. A lot of times you see motors and they will have a housing around it, and sometimes it'll just be plastic. But I think this is probably some sort of I would think that's a metallic,
Yeah.
some sort of something cast.
Okay.
We'll probably see when we look at the internals in just a second.
Right. It would
So
also, I
here,
mean, that's not
mhm,
necessarily true for these demo models, but I think
yep,
a cast housing is also better for heat rejection too, because ultimately those things are going to
yep,
generate a lot of
they're
heat
going to
as
get
they're
warm. They're going to
operating.
get warm, and they have
Yeah.
to handle a lot of the load as well. So
Right.
if you look here, this yellow um, actuator only shows up in one place in the bot.
Right.
The red one here, we see there's like 1, 2, and then there's like another 2 down here. So we have and we need 6 of them to make the bot.
Right.
Um, these orange ones are only needed for that. These are the real big boys. And then the green guys, these are the ones that are the yeomen. I mean, they are the ones that work. There's 3 up there. There's another 3 here as well.
Right.
And the purple ones, there's one behind here. So there's also 4 of them. And then we have this one here, which is also, well, there's 2 here because they need,
Right. Yeah.
so you have a
actually
total of
4
4
of those. Yeah.
So the yellow you have the least of, which is why I was kind of curious. It's like, well, then why don't you design it for like only doing one thing? Why do I have this thing here if it's not being used?
Right.
That's something I just don't quite understand. So that's one of the things to point out. They must have a use for it. And then that's just the fingers, which we weren't really able to see much of. But this is what it looks like internally.
Oh, also, I think it's worth noting that the planetary rollers, that shaft is actually looks more like a square profile.
Yeah, I think it's some of them they're square and some of them they're round, because they only are showing us one of them. And one of them I noticed that it is cylindrical, this shaft, and the others that they are square.
Yeah.
So it's like, okay, I wonder why they aren't all that way.
Right. But it keeps it, I mean, maybe it's when you have the pairs that it's round shaft. And if it's just a single one, then because you don't want that thing rotating.
See, what happens is this has one single axis to rotate about. So basically it can lock it in position and won't do it. The other one is actually a spherical joint. And because of that, you have to lock it out. You don't want to have it have any motion along that way. Right. That just, it will have like induced rotation. You'll end up getting it to sort of come around and bind because you only have a couple degrees of freedom motion along that axis that you need anyway. Right. So there's like one that you have a lot of movement and the other one's like, we allow a little bit. And it's meant more almost for slop than anything else. Yeah.
What do you call that one again? The one that's like the slop one?
It's basically, it's a spherical joint, or sometimes they might call it like an eyelet. It almost looks like this, but you see, this is cylindrical here, whereas the other one is shaped out to actually be spherical in there. Right. So you have kind of a spherical joint. And the problem is once you put a sphere in there, you have 3 degrees of freedom.
Right.
And what they want to do is they want to lock one of those degrees of freedom out on that thing. And that's why they make it square. And this one, they can get away without having to do that.
Right.
Now here, if you look at it, this is what I was talking about, is you can see right there, that's where that pin goes in. But if you look at that doesn't go all the way through,
Right. Right.
So to me, it looks like, and it does show up on the actual bots. The actual ones are out there. You can see it, and it really is there. And so it looks like they're just trying to put a little pin in there that will snap into place for whatever purpose. And I assume the ring that they put on there might have been, again, to be able to put their tie downs or something like that for the cables. I really don't quite understand it because it doesn't go all the way through. Yet we can see in the other one, it does go through. Now there's a couple of different images of the same things, just showing different parts of how they are engineered, the pieces that are in there, the strain wave gearing, which it's rather interesting. This is basically to get rid of hysteresis or backlash in gearing, because the whole problem with gears is that when you design them to be absolutely perfect, and you're coming up with these designs of these teeth that constantly make sure they're like in contact and locking.
Right.
And they will always kind of work in one direction. But as soon as you back up, there's like a little bit of slop. The other one moves before the next one gets to engage and move. Right. And that's always a problem.
If anybody has ever wound set the time on a mechanical watch, you'll know exactly what Scott's talking about.
Yes.
Like you wind it one direction and the minute hand and everything moves. But then as you rewind it backwards, there's like a moment where you rewind and it doesn't catch yet, and then the gearing catches and it moves backwards.
And so like a lot of robots, they use things called harmonic drives and everything else to try to get rid of the backlash. And sort of the irony is that rather than trying to design these perfect gears, you actually almost take advantage of imperfections. And that is the idea of the strain wave is that your 2 gears don't quite mesh perfectly well. And you basically have this kind of, and you almost make them elliptical a little wave. So there always is like this area that you just are in extreme contact. Right. And that kind of ends up propagating through the system as you rotate. And it just always makes sure that you are, no matter which direction you're going in, you are going to be locked in. So the strain wave, it's rather interesting design. When you first look at it, it's like, well, wait a minute, why would you want to do that? And it's like, oh, okay. So that's what makes sure they don't have backlash and that it works well. But again, we can see the design that's here kind of fits the design. If you look at this plate that comes in here, you'll see it matches in there, and you can see that they do have like a long bolt that goes through to pull these things together. So
Right.
You have a flange in the back that is pulled in using these long bolts that kind of come through here that also pull this cover plate in. And that cover plate, I think some bolts go all the way through and some of them actually go straight into to the housing directly on there.
Right.
So you can sort of
Right.
see how they're designed, and that's exactly what we're seeing out on the floor. And yeah, just, some more views of where actually the magnets and everything else are that you can kind of line everything up. So if you just go back to AI day 2 and look at the images I have in there, and then you can, compare them to what you're seeing, and you'll see that they match up really well. I don't see any differences.
Yeah.
And that would make sense. If you are 3D printing it, all you need is the CAD file and you can print that thing out exactly the way it is. And there's no
Right.
reason to make it differently.
But it is interesting that they haven't iterated on the design in that case. Now,
Right.
one thing that, wow.
Yeah. Now
Looking at
look
this compared to the mall versions, there is a lot of extra crap on
this
here.
is the mall feet. These are the mall feet. Okay.
Yes.
These are the mall knees.
Right.
But up here, when we start to look at some of these images, you
Yeah.
can see that has a slightly different luster to it than what we're seeing
Right.
on the floor. So
Right.
these to me look like they are the real deal. Again, looking in a little bit closer, we kind of see that. We can see how, definitely very shiny these things are.
Yeah, but also just a lot more
But
wiring.
now, but look at the feet here. This is not the feet that we're
Right.
seeing
Right.
over
Right.
here.
Yeah.
Something that's also interesting is that if you look at the hands, the hand that's here and the hands that's actually being used to go there is slightly different. They
Right.
seem to be made out of different material.
Right. There's also no
They look the
kneecap
same.
on the
Yeah.
guy that's walking too. So
Yeah, this one seems to be very shiny. You see the
Right.
hands here very shiny, where these seems to be more gray, more muted.
Yeah.
So it's something
Right.
different. So this may be not fully functional compared to what it is, but they are demonstrating. But I'm looking at this motor here, and it seems to have some more details on it. So it looks like
Right.
it's more like the real deal, and obviously all the all the wiring and everything that's in there.
Yeah.
And here the feet are evolving a little bit, but they're still kind of flat to get an idea. But again, if you look at the knees, you'll see the knee covers, they're not the same as we're seeing in the mall.
Right.
And we can see that here. Basically it's sort of what you would wear for volleyball practice.
Right.
Those knee pads,
Knee
because
pads.
you're always kind of going on down there. And so it might be that they've decided for now they want to come up with something that's a little bit more robust. And again, you'll see the covers aren't even on here.
Right.
But
Right.
we know it does have covers, but for some reason the covers are off right now when they were
Right.
doing the testing.
And
But
and look at the bicep area and the hands on this guy. You can see I would consider that to be nylon printed, 3D printed.
this
That guy
here probably
and the
is.
hand.
Yeah.
Yeah, and then so that's why I think
Yep.
the ones in the mall are not nylon. I think that they're actually probably aluminum.
Yeah,
But-
it might be something else, but this here, I mean, this is very, very shiny compared to what we're seeing in the mall.
Right,
So that's definitely aluminum. And then of course you're seeing trying to figure out the routing of the cables is just going to be all kinds of fun coming
Yeah.
around
Yeah,
through here.
That's one thing I definitely noticed from the mall version, since they don't have any cabling there. They look much cleaner than this. This is pretty.
Oh
messy.
yeah. And again, you'll notice they're not wasting their time putting the belt buckle on here.
Right. Very interesting. But of course, this is almost a year ago now. Or wait,
Yeah.
no, sorry. This is 2023. Sorry.
Right.
I was
And
thinking
again,
about
if
I
you
was
look
thinking about
here-
AI Day. That was almost a year ago, but this was a few months
Look
ago.
there. You see that hole there? That's where those pins are going.
Right.
So that's what I'm saying is that, it shows up in a lot of these images. Let me see if I have a better one. Oh, I don't think I do, but it's showing up in the real deal that they're there.
Right.
You can sort of see that they are. And if you go through this video on your own, you will notice all those things. All those details are showing up.
But of course,
But
unused in this case, as far as I can tell.
Yes. And even then, I mean, you're kind of right. If I look at, this material here is a much more matted,
Yeah,
different material than
that's
what
a
we're seeing
plastic
here.
nylon kind of.
And then this here, I don't know, does that fully match what we're seeing on over here? It might be a slightly different cover. It's hard to tell.
No, I think the guy that's on the table is the newest one, because he's got a kneecap. He's got looks like aluminum biceps and hands. So I think he's the newest one.
And, we see that these are operating with the covers in this case versus what we just saw out in the wild where they were
Right.
probably taken off just
Right.
because they're doing engineering on it and servicing and everything else. So they're not quite worried about it. But
Right.
obviously the covers are going to have to work when they're are indoors actually functioning.
Yep. So, wow. It is pretty shocking when you go and look at this, how different these look than the mall ones. It just it is sort of like when you like when I like looked at the mall ones, I was like, yeah, 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 that's the same thing as what we saw. But then I'm like, oh no, 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 those ones are very clean. They clearly don't have cable runs all over the place. They're
Mhm.
they have the advantage of not being functional so that they don't have to have all the wiring in them. So that's going to require it's going to require a lot of work to get all of that cabling like inside. Maybe, and that could be one of the other reasons for all of those external, maybe they're pass-throughs for cabling. Um,
Maybe
yeah.
that's one possibility, but it seems like an awful lot for. Well, I don't think the cables would go through some of those holes. That's just they're just too tight. It could
Yeah.
only be for like an anchor point to
Well,
hold
and
whatever
because of the
you're
fact that
using to route them.
yeah, they're like hard edged unless you put like a
Oh, they're hard
plastic
edge. Your
plate.
cables will wear out.
Yeah.
Cabling packages wear out all the time.
Yeah.
They're always going over rough edges, which is the first robots that were out there were very rectangular in shape, very boxy. And
Right.
spot welding robots, one of the first things that was always failing on them was the cabling packages because they were just running over those things constantly. And it
Right.
was in when ABB came out with the IRB 2000, they made everything very smooth.
Right.
So it was very nice. And they were kind of criticized by all their colleagues because they referred to it as being a very sexy looking robot because it had all these smooth edges and everything. And, they came from Sweden and everyone was just kind of joking. It's like, oh,
Right.
what are they doing coming up with that? And it turned out it's
Yeah.
like, it was a function. There was an absolute reason for it. It was to
Right.
make sure your cabling packages didn't get snagged on it and broken. And also it was a safety hazard having sharp edges.
Yes.
So there's a
Yes.
lot of utility to doing that. And yeah, cabling, it's you can see in all the other humanoid robots out there, they're also trying to figure out how to package everything. What
Right.
is going to be the best way to do it?
Yeah, I'm sorry. I'm just sort of looking through here, like somehow this cable is being run down the outside of this
Yeah,
the arm, for
yeah,
example.
yeah.
The lighting is very poor in these things.
It's hard to
Very dim.
tell. So you're gonna have to
Yeah.
I think they may have some sort of anchor there and some sort of uh not wire, not but something to
Yeah.
kind of hold it on there to keep
Right.
it in position.
So,
And so what that means is that you probably need something for that, but you can't really tell from that image whether it's there
yeah,
or not. So
exactly.
maybe that's what it is for. Is it's purely just to be for cable management, nothing else.
Right. Right. Yeah, because there's something that's holding it next to the elbow right there. I can't tell what it is,
Yeah, it
but
has to. You want it kind of close, but not in too tight because you don't want it
yeah.
flopping away and wrapping around everything else. So you want it
Right.
to be there, but you want it to be loose enough that the cable can keep on sliding through very easily.
Right. Yep. Yep. And there's
And now
clearly
how
some
you
sort of
manage
sheet.
that and
Yeah.
cover all that up at the same time, that's going to be interesting.
It is going to be a challenge. It isn't. I mean, I think Elon said that. So people are like, oh, yeah, this was easy. And Elon's like, no, it actually hasn't been very easy. So,
The hardware's been, yeah, everyone just thought, oh, it's just FSD. And he just said, oh, the hardware is a little bit harder than we thought.
yeah. Yeah.
So that might be part of it.
Right. I think one of them is just, again, there's the scale aspect. When you've got an entire car that's several meters long and like 2 meters wide, and it's a big object. So you have big pass-throughs where you can put your cabling and all that kind of stuff. When you get to a humanoid sized robot, it's all of that has to be shrunk down. It's a lot harder to manage all of those pieces and bits and bobs and everything that have to go into it.
There's just not enough space to route stuff there. In the
Yeah.
car, you can always find, there's like a little channel here, something like that we can
Right.
run something through. It might be a bit annoying to run through there, but we have the space and it's out of the way. We don't have to worry about when the drivers and the passengers get in there, they're going to be tripping over cabling.
Right.
But in this case, like we don't have any room. So that's always been the problem with, the wrist area is that a lot of the robots have these really big bulky wrists to be
Right.
able to get all the services and everything through it. And this has been the challenge with the humanoid robots. Well, for that wrist, we need to have 2 degrees of freedom going back and forth.
Right.
How do we manage that? Do we actually put a motor? And there are some of the humanoid designs out there where they're putting a motor there, but once you put it there, you get something that's pretty bulky.
Yeah.
And then it only deals with 1 degree of freedom. You want to put the other one in there, and suddenly gets even bigger.
Right.
And then you still have
Right.
to get all the surfaces out to the fingers. So you see what Tesla has done is that they've got the movement that's going on there by having the 2 servos back here. So
Right.
they're behind that to try to do it to make sure the wrist is very, very thin. But you need to get the services out to 6 motors that are there. And at this point, they're not really going through the wrist itself. They're kind of coming around like this. And if you think about it, our bodies have to do it as well. Our veins and our arteries have to also get themselves through there because we need a blood supply out there. So that's already a challenge. So you get some hosing you got to deal with.
And don't forget the muscles too. I mean, these
don't forget the muscles for our hands are back here. There's virtually nothing out here. I think there's just fat out there. I don't think there's really any muscle. And that we, of course, can see all the tendons.
I think we have a little bit this direction. There's some muscles like this.
Maybe there was there because I get like muscle cramps there sometimes. Okay.
Yeah.
But the bulk of it is all back here in our forearms, all dealt with the fact that and again, you're routing all those tendons and everything through that weird joint right there.
Yeah.
Everything's got to pass through that joint, and how you keep that nicely compact is really something else. And not only compact, think about it, you've got to have a certain degree of strength there as well.
Right.
So if you're carrying something very heavy, everything is going through that joint. It's got to be able to deal with that.
It's pretty nutty. And I mean, the evolutionary solution is to have, how many bones are actually in there? There's a lot in this.
You look at it and it's
messy.
It's kinematically, it's very hard to model that. So I mean, even in these labs where they're looking at articulation, they model it really simple. Gary Snyder says, you won't believe how simple it is. It's like we modeled exactly the way a robot is. Like you got a rotational axis this way and another one that kind of goes through it this way. And that's how we model it. And they give it the names, like flexion, abduction, roll, whatever, the same thing. They don't really model kinematically. Now, I'm pretty sure there's some biomechanists out there that have like really drilled down to try to understand what's going on with all that to highly detail it. But normally it's so hard to model that correctly. They take kind of the very simplistic viewpoint, and that is just imagine it's actually a robot. Model it kinematically that way.
Well, I'll tell you from 3D animation packages, they are stuck with all nodes in a graph. It's a directed acyclic graph is the way that most of them work. And so all nodes can have multiple children, but only one parent. But if you look at the entire arm, there are 2 bones in here. So you've got multiple children and multiple parents effectively. So that's why it's really, really a pain in the ass to model.
To model correct. Yeah, exactly. Yeah. So we ignore that in a lot of the human models that we have.
Well, but then you look at like even that toilet robot, that was a very complicated looking arm to do a relatively.
But it is serial. So it wouldn't be that hard to do. And now you do have some robots where.
No, but I'm saying compared to this, this is much more elegant in terms of the outcome of it.
Yeah. If you look, But again, if you want to talk about, multiple parents.
Right.
If you look at the, just the Optimus arm, the way that thing is modeled, that also, you can't just do it with a very simple acyclic graph. You can fake it. What you do is you determine that, well, I'm really just going to have one parent here. But as the structure comes through, I'm basically going to come through in that node that would go to this parent, which is way down there. I figure out what I need to do with a node up here to make sure it appears to connect to that. So you have these constraint equations in there that will give you the illusion that it comes together. And we have to do that all the time in our software because we have these robots that have a parallelogram kind of mechanism for the actuation. So that's one way of modeling it. But then it gets really nasty when you start getting into like these Stewart platforms. And trying to figure out how all those things flop around and move, because it is not a serial link, it's a parallel, what they call a parallel kinematic.
Right. Yeah. And that's where things get nightmarish and in terms of the math and everything too. So it's not, none of this stuff is trivial, either from a hardware design standpoint or from the software that has to operate it.
If we go back, I think I pointed out in an earlier video, it was the investor day or the shareholder? I can't remember when. I think it was the shareholder meeting where they showed the operator with the helmet, teaching the Optimus off on the side, and so his movements were also being mirrored in the simulation. But when you looked at the hand movements there, it wasn't staying connected, and it kind of was falling apart. And I was like, oh, come on, I know the solution for that. So it's something that can be done. But again, it's just like, it wasn't that important to what they were trying to do, because they're also probably modeling it as well, this is what we want the wrist to do. So they are modeling it as if those actuators aren't there. So
Right.
it's like, this is just what we want them to do. We just want to see it. And the actuators are there. So it kind of looks kind of right. But then they have to do the next calculation, say, well, this is where we want to be. What do the actuators both have to do in order to get to that particular orientation or configuration?
Right. Yeah. It's
And
it's
that's basically,
complicated.
it's like a second, and it's almost like a back propagation. It's
Right.
like, whoop, you do this and then you figure it out and like, all right, then we kind of come back.
Right. Which is again why this was so complicated before the advent of sophisticated neural networks and stuff, is trying to do this, like you said, you were doing these simulations in the 80s, but to try to actually take that, it's complicated. It's really hard to make that stuff work if you're doing it piecemeal. And the problem
Yes.
is that every degree of freedom is kind of an exponential add-on. So, when you start talking about having 30 or 40 degrees of freedom in a robot, it's like, whoa, that is a really big number of possible outcomes. So,
Yes. And especially if they also understand what they're doing,
yeah,
then it's a lot easier to kind of coordinate it. So we have such a good sense that when we move one of our arms, the rest of our body just innately already knows instinctively how to move itself around to compensate what's going on. But when you try doing that calculation, it's sort of hard. Oh, how do we
yeah,
how do we actually account for that? And it's just because through our experience in life, we know that when we do these motions, it's more comfortable for us to maybe shift our weight or do something a little bit different when we try to do it.
right.
And we can already imagine in our head what that's going to be like.
Right. I think you could take the example of a professional athlete, like take a tennis player. So, if a person who's never played tennis before gets out there, yeah, they're going to swing and they're going to do more or less the same thing that a professional does. But a professional will spend literally 15 or 20 years getting from the place that amateur is to doing it as almost perfectly as possible. And all of that is just refining it down from being kind of sloppy and
It
close
really
to
is
getting
chasing the nines.
really
Yeah.
exact. Yeah. And
Yeah.
it takes
Yeah.
a long time, a
Yeah.
really, really long time, even for us
Yeah.
humans who are good at
Yeah.
this to
Yeah.
do that.
Yeah. I mean, if I'm out on the court and someone is like hitting balls to me and doing it pretty reasonably, so I don't have to run after it,
Yeah.
I can swing it and I can usually, almost always hit the ball
Right.
and maybe get it to go over the net.
Right.
And I can probably do that with a certain amount of consistency. The thing is, I'm not always getting in the sweet spot. And
Right.
sometimes I'm getting it right on the rim. And of
Right.
course, it's not going exactly where I want. And that
Exactly.
professional, I mean, he just, that same one, he can decide it's going to not only go over the net, but it's just going to go over it by that much.
Right.
And I can tell you exactly
And it's going to
where.
go over
So,
there. And there's going to be a huge amount of extra speed on it because of the
and there's
exact
going to be
timing
spin and
the-
everything else. And so
Yeah.
it's like, so in a sense, what I'm doing, I'm already the first nine. And I could say like, I'm 90%.
Yeah.
Hey, I'm 90% there, of
Right.
what it takes to be professional. But those other nines are,
it's
have way
really
more significance than you think.
right.
So the guy who's 99 versus 99.9 is the guy who goes to Wimbledon versus the guy who doesn't.
Right.
It's simple as
Yeah.
that.
Yeah, yeah, and but that, I mean, I think that also should give people a little bit of respect for full self-driving, because full self-driving is at least 99% of the way there now. It's just that every time you add a 9 is not just a linear progress, it's an
Yeah.
exponentially more difficult addition.
Yeah. Now do we want to touch on, what happened to Cruz last week?
Oh
Because they got
gosh.
involved in 2 accidents in the same night.
Right.
But if you really look at it, it was the fault of the human drivers.
Interesting.
their
Okay. I
behavior.
heard it
So
was
that,
cellular connections had gone out or something, but maybe that was
well,
a
that
different.
was other stuff where they get
That was
tied
other
down.
stuff.
No,
By the way,
literally
I should advertise this because this is your shirt, but I wore the I'm on an
Oh,
ego trip, right? For like, that would be for full self-driving, so people can get that in the merch store.
okay.
I
So we
noticed
can
you
get
were
it.
wearing your robot love shirt.
Yeah,
So
well, I
yeah,
mean, we are talking about Optimus,
I know exactly.
Uh,
So I knew that full self-driving would come up, so I knew I'd be able to.
so yeah, so I think the first one was that a cruise was taking a right turn at a traffic light. The light turned green, and a car ran the light.
Oh,
So another vehicle ran the red light, and then as it went out, it sort of noticed, oh, there's a car coming, and it just stopped in the intersection.
right.
And of course, what ended up happening is that the human driver was anticipating he was going to continue to go, and decided to kind of veer to the inside rather than going to the
Oh.
outside. Now, if you'd gone outside, because the interesting thing is, I was looking at it, is like the first lane that he basically was blocking was the bus only lane, anyways.
Right.
And the cruise was not blocking the second lane. So if the driver had kind of veered a little bit more to the left, probably would have got around. but you could
Right.
see he anticipated the cruise is going to go, but then the cruise stops. Uh-oh. But the mistake that I think the cruise made, if you're going to give a little bit of blame to it, is that just because the light's green does not mean you have the right of way. You know,
Yeah.
technically you have the right of way. It does not mean you should proceed. That
Right.
you should check to the left. And if it's seeing it, I mean, any human driver would have seen that car coming at a great rate of speed and said,
Yeah.
I don't trust him. I don't
Well,
trust someone
okay,
with
we should be a
with
little
blinker
careful with
signal
that.
on
A
until
lot
they
of
actually
human
do.
drivers are distracted and not paying attention. A human
Yeah,
driver
yeah.
who is paying attention
But
would-
anyone who's paying attention would look at it and say, I don't think he's slowing down. I think he's running the red light. So usually you can tell that. And of course, that's what a lot of the Tesla safety system does, is it detects someone running a red light and prevents you from kind of getting out of there and going in there.
Yeah.
So it could clearly see it. And if it didn't see it, because from the videotapes that were there, it looks like you could see that driver was coming. It should have been able to detect it and not even proceeded.
Right. And
And
in Tesla's full self-driving defense, I've had that happen a couple of times. When full self-driving is driving, the light turns green, and I go, why isn't the car starting? And all of a sudden the car goes zoom right through the
comes
intersection.
right on
It's
by.
like, whoa,
Yeah,
okay.
yeah. So it
Yeah.
notices that, and a
Yeah.
computer should be able to do that because it's able to do that kinematic calculation and be able to look at it and say, this car is accelerating. It's not, it's not decelerating, it's accelerating. And you can already do the calculation of like, well, wait a minute, if it continues on that path, it's going to go on there. So it's making this assumption that the other cars are going to behave the way they're supposed to, and you can't. I mean, that kind of gets you mistaken. I think someone said something, if I remember, that what should be put on most tombstones is he had the right of way.
Yeah.
It's like so you had, and then the next one was actually with a fire engine. And so again, it was like going through a red light. In this case, it was worse because the first one, the cruise was empty. There was no one in it. The second time it had a passenger, and it had the green, but a fire truck was running the red light and running the red light in the wrong lane. So basically where the cruise was getting to pull into.
Right.
Now, again, you could say, oh, it should have been like listening to the fire engines or notices, stuff like that. It's like, sorry, emergency vehicles are required by law to stop at all red lights as well.
Are they really?
Yes, they can't. They can't assume that you can just run on through there. They must proceed with caution, and they must make sure it is safe to go. Now, when they get there and they know they can run the red light, they're allowed to do that once they know that. So they must slow down or come to a stop. And then you're in the wrong lane at the first time. It's like, I think a lot of human drivers would have made that same mistake.
Right.
So to me, it's like, but the thing is, it's a black eye for autonomous vehicles.
Yes.
And obviously for cruise, everyone's going to dump on cruise for that. And I'm like, it's like, the problem is, if everything was an autonomous vehicle, this wouldn't have happened.
Right.
They all would have obeyed the law.
Yeah,
It would have.
Yeah, that's actually true. I mean, emergency vehicles seem to be, they are a real bugaboo for Teslas too. Because even like if I drive down the highway or something, and it will happily pass by a police car with its lights on, stopping somebody. And then there'll be a weird reflection of lights and they'll say slowing down for emergency vehicles. And I'm like, it really seems to have a very hard time figuring out what an emergency vehicle is and quite what to do with them.
Right. Yeah, exactly. And that's why I disengage right away. I mean, it's like, part of it's like, well, it would be, it needs the training data, but at the same time, it's like, no, it's just, I want. So unfortunately right now, there are so many situations that I don't know enough about how it's going to do. I don't know how far to push it.
Exactly.
And if I do, I am just absolutely on edge. My foot is like just ready to go to the brake pedal. I'm like this, holding it, just waiting to see what it's going to do. Yeah. And then we'll disengage it immediately.
Right. But this is one of those situations where, again, the Tesla methodology for doing this just has an inherent advantage, which is that you do have a driver in the driver's seat. So while it's still not perfect,
hopefully it sees that you disengage. It's like, I'm disengaging. And then it's saying, okay, what is he doing right now? Right. And then that comes into corpus to say, oh, that was the way that we should have dealt with that particular situation. But I mean, maybe it knows what it was going to do, and then was able to compare the two and say, oh yeah, that was not the right thing to do.
Right. But I'm just saying, like oh gosh, who was it? MSNBC that did that, the cruise drive around where the car like got stuck for 20 minutes before the guy showed up to like move it. I'm just saying there's a big advantage to having the driver actually in the driver's seat and be
Oh
able to
yeah.
like
Yeah.
take over and move the car 'cause it's not
Immediately.
stuck there for 20
Absolutely
minutes.
immediately. Yeah. So
Yeah.
we're getting way more training data. We're getting it
Right.
outside of just a geofenced area. It's like all over the place. So,
Right.
and again, I live in Edge Case, Florida,
Yeah.
where every day I'm seeing like a new weird kind of behavior.
Right.
And a lot of it is just behaviors of other drivers.
Right.
And it's suddenly changed again because for the past month or so, everything was good, but now school is in. And it's like,
Yes. Yes.
whoa, okay, now it starts to get a little bit
Right.
crazier again and dealing with that. So
Yeah.
yeah, we have these different seasons of different kinds of drivers.
Yeah. Yep. I definitely noticed that here too when I drive into school now, of course, because school started that it's very crowded. There's a bunch of people who just walk out into the road without paying any attention to whether they should be or not, and just assuming the drivers are going to stop. And it's a lot more challenging all of a sudden when students are around. So
Yeah, and again, it's like I think I learned the other day exactly what, well, it varies from state to state what the rules are when a crosswalk. So again, a lot of pedestrians assume they just have absolutely the right of way when it
right.
comes to a crosswalk. And the thing is, they actually, well, they have a kind of right of way, but only when it's actually safe to go. So like, so if a vehicle
Right.
is driving a legal speed and is entering a crosswalk and there's no pedestrian in it, and a pedestrian is not even making the attempt to go in, as soon as they get to that crosswalk, they can't just cross and assume that the car has to come to a screeching halt.
Right. Right.
So they really are obliged also to make sure that when they enter it, they're entering it in a state.
Yeah.
But that's not every state. Some
Oh,
states
really?
will be the other way
Interesting.
around. As soon as that foot's in there, it's like the driver is completely to blame.
Right. Right. Yeah. It seems like within the realm of reasonableness, it's like if you're driving 35 miles an hour and you're 10 feet from the crosswalk, the pedestrian
can't
just
stop.
should not the laws of physics dictate that it's going to be really hard for you to avoid them if you're
Yeah.
going that. Yeah.
Exactly. And again, you can sort of make that argument with a lot of these communities that will have like a really quick yellow just to catch
Right.
you at the red.
Yeah.
And
Yeah.
I think there was like a case where an engineer went into court and he proved that, because the light like gave you like 1 second and he was going the speed limit and where he was, it physically was not possible, or the amount
Right.
of G's was going to be there. And eventually the judge realized like, oh yeah, I guess, because it's basically, he was making the argument under entrapment. That
Yeah,
it was,
exactly.
the light is intentionally timed for
Right.
entrapment purposes, not for safety.
Yeah. Yeah. And that, wow, I can't believe a police in a small town someplace would do that. Wow. I'm
Oh
shocked.
yes,
I'm
shocking.
totally shocked.
Absolutely shocking.
So, all right. So we drifted off from Optimus a little bit, but I think that these all, relate to each other. But final takeaways from the mall Optimi. What do you have?
Well, they'll be able to tell a little bit more when they finally get one down here. So we
Yeah.
can take a
Okay,
look.
there
But
we go.
I think, it seems that it's become an attraction.
Right.
So my understanding is it seems like they're showing it more in the malls than they are in the dealerships, because people down in Florida said they were going to end up in the Tesla service centers,
Right.
because I thought that was more through traffic, but it looks like it's actually going in the showrooms of the malls. And
Right.
that makes more sense, because if someone is going to the Tesla service center, it's because they already own a Tesla or they're
Yeah.
about to pick up their Tesla. So it's not like
Yeah.
you're getting a new customer.
Right.
But if you want to get more foot traffic in your mall, then just put Optimus there. And again, people are going to go there as soon as they hear about it. It's like, oh yeah, I want to go check it out, or what is this thing? And
Well, and I would think
that first
from
video,
mall,
the
from
little
mall
boy that
owners,
was there, how intrigued he was looking at that thing. So
Right.
I think a lot of parents just, yeah,
Yeah.
I want to just have my kids come out and take a look at it and see what it is, see what they think.
Right. Well, just
I guess
imagine
the
if
other thing
you're-
is, if that thing is actually 3D printed,
yeah.
maybe it would actually be cheaper to get an Opticin than I thought, because it's going to end up on the Tesla shop. You just know it is.
Right.
Um,
The non-functional version, but
the non-functional
that
version
would be
is going
pretty
to,
cool.
yeah, if they're 3D printing it out, then the shipping costs won't be that heavy or that
Right.
much.
Right.
And yeah, and then maybe it'll be a bit more affordable than, whatever it would be. If
Well, even if it is heavier, just think they can kind of double up, because maybe you have to go to the Tesla showroom or something to pick it up. So they just throw it into the back of a Model Y or something, put the seat down, throw a couple in the back as it's being transported across the country to that place, and then you pull them out.
Yeah,
So.
potentially they could do that. Yeah. And then you just go to the Tesla shop to pick it up. Yeah.
Right.
That's that's another brilliant thing is like, yeah, you have to pick it up actually in the store. You're
Right.
not going to send it straight to your house.
But man, they could charge a couple of grand, and there would be a lot of people who wouldn't bat an eye for
Easily,
picking that
easily. I
up.
mean, how
Yeah.
much was the little Cybertruck, the Radio Flyer Cybertruck? That
Oh,
was,
yeah.
I'm trying to remember. Was it 5 grand?
Yeah. It was
It was
expensive.
pretty expensive,
Yeah.
and yet sold out like that. So
Right. Right. I mean, how much have we paid for the beer and for the tequila and for the terrible smelling perfume?
which
It's-
is right here, completely locked up like it should be.
Exactly. I don't even know
You
where
notice
mine
it
is
hasn't been
because
sitting up there for a while. I forget to keep bringing it out for a reason.
right. Well, I had mine out. It was displayed, but then of course when the flood happened and everything had to be moved, I don't know exactly where. I hope oh no, I remember what I did. I put it back in its case and boxed it up because I said this is the one thing I do not want to get dropped on the floor.
On the floor, exactly.
Exactly.
Be a
So,
second insurance claim.
I don't even know how you make a claim for that. I was like, you did what?
Something about burnt hair. What's this?
Yeah. I can't live down here anymore. It stinks. All right. Well, thank you so much, Scott. This was very elucidating, and we talked about a lot of stuff.
Mhm.
Don't forget, people, after the end of the official video, we're going to have some Scott is regaling us of stories of the KOA.
Yeah, that's my stand-up
campgrounds.
comedy routine here.
There we go. About being the Dutch boy with like storm.
Yes,
So,
yes.
yeah. All right, everybody have a lovely day. We will see you in the next one. Bye-bye. Weirdly enough, it doesn't actually clean the toilet. The one thing that I was like, wait, it doesn't actually have like a little scrubber thingy that cleans the actual toilet bowl.
It didn't
Which-
seem like it. It lifted it and sprayed something around.
Yeah,
So we can
yeah.
look at it a bit closer. It was hard to tell how much it actually did. But again,
Okay.
I'll get into a little bit of the details
Okay.
on that from what I've learned about what goes into cleaning toilets. Let's say I was an expert for 6 summers at cleaning toilets.
And also, of course, the toilets generally don't look as nice and clean as that one does. So when you come in,
Yeah.
it's usually pretty gross.
Yeah, yeah.
So yeah, especially because you said you worked at KOA, right?
Yeah, our
Your family had
owned
one?
We had a KOA for 6 years, from 1970 to 1976
Wow.
in Ossipee, New Hampshire. Campground's still there. It's called Beaver Hollow Campground. It was originally a KOA, but after we realized that, let's say financially, it wasn't in our favor to remain in that franchise, we went independent. And
Gotcha.
yeah, I mean, it's like everything you learn about running a small business and customer relations and all that stuff. It was a growing experience. I was 12 at the time when
Right.
we started building it. So I learned a lot about digging trenches and painting and doing plumbing and electrical
Gotcha.
and then everything
That's-
that can go wrong with a septic system.
Yeah. Because I assume that's what you had was a septic system out there. Not
We
a,
had a septic system with a leach field
Yeah.
and some pumps, so that's why I know a lot about overflows and sump pumps and how they work. And
right.
and
And,
and
of
let's
course,
say-
I'm finding out all about that since I'm in my stupid little extra studio, like
and
temporary studio.
and settling of the ground and what it does to PVC pipes. Because at that time it was like they were just starting to use PVC pipes for a lot of stuff, because before then everything was kind of cast iron. And so you
Right.
had a lot of these PVC pipes that were coming from the different bathrooms and then going into a very large holding tank. And sure enough, it would settle during the winter. But the first stress test was always the 4th of July weekend. And that's when you discovered that the pipes would actually crack. And one year it was the men's room, and the other year it was the woman's room.
Oh,
and-
jeez.
And things like backing up and not working and having to do trench work. Wow, it's like the
Oh.
campground is full, and then of course, the genius thing was like the actual main building was sort of up, at a ground level, and then there's like a little gully that came down
Right.
there where we decided that's where the pool was going to be. Well, right between the steps that went on
Oh.
down there, that is actually where the septic tank was. And at the
Oh,
bottom of that was where the basically the sump was that then pumped it up to the leach field that was behind it. So what
Oh,
ended up happening is they had this gravitational effect. And then like, I think 1 year, see 2 years, it was like, well, listening, and 1 year, the sump pump failed down
oh,
there. And it's like, so the overflow, and it's like, oh my God, it's like right next to the swimming pool. And it's like 90 degrees and everyone's out there using it. It's like, oh boy, that was,
that's a high stress environment. You don't think
uh,
about that, but man,
the other thing that 1970 was when they first had a lot of EPA regulations went in, because there were just all sorts of things that we were doing to groundwater, and campgrounds were just notorious because they
right,
had these sewage hookups, and the sewage hookups were just always breaking and leaking and really polluting a lot of lakes and streams and everything. So they were
right,
clamping down. So when we built our campground in 1970, at that point, there was like, you could not get a permit to actually put in sewage hookups. So we only had water and electricity. And like
wow,
all the others were grandfathered around us. So we're like brand spanking new here. We don't have the one thing that everyone would like to have. And that
right,
is a sewage hookup at the campsite.
right,
So that really put us in a bind. And we were doing that. We did have like a dump station that was like, a big holding tank
right,
that, but then the trailers would have to drive around. So if people were using their trailers, they would then, you know, once a week or once a month, have to drive around and dump it there. So that
right.
was kind of inconvenient. And then around that time, this was happening, like some inventive souls went out there and figured out how to come up with a solution, and something that, I mean, it goes under like names like the honey wagon or something like that. Basically, it's a small trailer with a holding tank, and you go up and you pump out a trailer, and
Oh,
then you bring it over to the dump. So that way they don't have to move it. So, you would charge them like $10 or something, and then you do a
right,
run,
right.
in the afternoon
But
every
that puts,
day.
I mean, that puts a lot of stress on the holding tank too, because suddenly when you dump an entire trailer's worth of
Oh,
like,
that's 10 times. Oh, well, see, these holding tanks were, what it was when we ordered this thing. We said, wow, this is just amazing. These guys came up with it. And all they did is they just took a bunch of bits and bobs that exist and threw them together. So the trailer was just a skidoo trailer. And the
right,
holding tank was one of those fuel oil tanks that you had in your basement, in the Northeast. So basically
right,
that's what it was. It was a pretty big holding tank. And then they used swimming pool hoses and, just a bunch of other stuff. And of course, when they sent it, it was like an IKEA kit you had to put together. The problem was they weren't really good at making sure you had all the, let's say, equipment, hardware that you needed. So there are a couple
right.
pieces that were missing. And one of the problems is that where our campground was, the closest hardware store was like 30 miles away in every compass direction,
Oh,
and they
gee.
usually close at like 4 or 5.
Yeah, yeah. Because I
So,
remember, yeah, back in those days, they didn't have Walmarts that
oh
stayed open.
yeah. And
So yeah,
so it's like we had to see what we had, and we just kind of it's made do with what was there to test this thing out, because we're just all really excited about it. And that's where I learned like a lot of things. And like the first thing was the idea of what resonance is, and how check valves worked and everything else. Because you think they'd have a sophisticated pump, but they didn't. They just had a mechanism that basically had a plunger with
really,
yeah,
really,
basically you had a rubber diaphragm that just got pushed up and down, up and down, up and down. And so it created a squeezing force, right? And you had a pump that went, a piece of section of piping that came in, the section of piping that went out. And so the long section of piping is what you went out to the trailer. And it
right,
had a check valve in there to make sure that when you pushed down, it didn't go that direction. It had no
right.
choice but to go this direction. So then you had something exit that came out. The thing is, you need like 4 pipe clamps for that whole system to work, and they only sent 3. So
Oh, jeez.
we put them in where we thought were the critical places, and the last one was the one that actually went into the drum. And now we
Oh,
figured, well, what we'll just do is like we'll just hang it in there. It'll be no problem. Well, thing is, there's a resonance frequency. This is going zoom, zoom, zoom.
it's
And then you
supposed
get this section of hose that goes, zoom, zoom, and eventually it just goes out and becomes this fountain of going. Yeah, I remember that. I was the youngest one, and like my father and my brothers, they're all like looking over at the connection, because the thing about these is like every single travel trailer, of course, had their own sewage hookup. There was no
right.
standard, just like there was like no NACS connector.
Oh yeah,
There
yeah,
was like every standard. And so these guys had come up with what they said was like the universal connector,
yeah.
which it connected to everything and nothing all at the same time, because none of those connectors would ever be perfect for any of them. They would just kind of make do. And
Jeez.
so, you're just kind of like nervous that there's going to be leaking over there. So everyone's looking at
Right.
that, and like I'm noticing something. And then I just look around, and I just like in slow motion, I literally yelled the perfect thing at that point. oh shit, while I'm running over to where the plug is, and it's like trying to pull that thing out as fast as I could. It's like, oh, and that was the first day, and everything went downhill from there. I mean, there were just like stories galore of like mistakes that they made because it had like a gravity feed underneath it. So the way you went to the dump station is you had a section of piping. Of course, that section of piping was PVC. So
man.
guess what happened to PVC after like a summer or two, driving around over dirt roads that are bouncing, stuff like that. We're on the way to do a run, and it's like suddenly that PVC pipe decides to break. Well, the thing that stops the flow is not up in the other end. It's like at the end of that PVC pipe, which is now broken. And so meanwhile, that thing is just like, and of course we're too, we hated we never went to the dump station until that thing was full,
right.
Rather than just like after a run, you just go over and empty it. So, it had just been sitting over there for maybe a week or two, half full, 3/4 full. So it's like, oh boy.
That's disgusting.
Yes. And the funny is like, so our thing had, the nickname for this thing was Slushy Baby.
Boy, that must have stunk too. I mean, not just like.
Well, see, it gets even worse, John, because what happens is that we're going through. So we had this parked in the back section of the campground. We had like drive through there through the area where the tents were, and then we would come up to where the travel trailers were. And just as we're going up there, my brother is like looking in the rearview mirror, and he notices something's wrong. Fortunately, and he stops, and we come running on out. And like, oh my God, it's there. And he's trying to figure out what to do. And of course, he knows by the time he gets it off the trailer, it's going to get worse. But he knew that because it was like a skidoo trailer, it had a break in it that allowed you to like kind of get it up halfway. So he kind of broke the trailer in half, gut it up, so it wasn't leaking as much. Right. And then he's like holding the thing up there, and he yells at me, he says, "Scott, do something," And I'm like, what am I supposed to do? So I'm like, I'm the little Dutch boy. Bam, hands right up. Again, as soon as I was like, do you realize you are just holding back a shitstorm? And basically that is like ragged, broken pipes that your hand is up against, and I'm like, oh my God. And like the nearest doctor's office is like further than the nearest hardware store.
Right.
And it's like, oh, this isn't good. So I'm sitting there holding this thing back. And meanwhile, like one of these campers comes up and he starts complaining. He goes, "It stinks back here." I'm like, buddy, you know what I got in my hand right now?
It's like,
it's
all I have to do is
come your way. It's like, now is not the time to complain. Oh, yeah. And then, and then things that would get trapped in the check valve. And my brother learned something about back pressure. It was like the check valve was stuck, and he didn't realize he needed to get a little bit of pressure out of the system. So he just opened up the check valve. And it's just a bunch of stuff decided to come out. And of course, as he opened it, there's like 363 degrees of direction this thing could spray out. It sprays out in the one that's like straight between his eyes.
The funny thing is, I'm thinking about how when we had our flood that officially had some sewage water in it, how they all put on hazmat suits and they like tore out the bottom.
We didn't have anything like that.
I was like, no, you guys are there with your hands.
That's why I've got such a good immune system, man. It's like I've been exposed to so many people with COVID, and like, nope, not getting by that brick wall.
Yeah, there you go.
It's like there's something about as a kid and playing in the dirt and eating dirt and everything. It's like, well, I get exposed to a lot of bacteria in my youth.
Oh my gosh. Okay. Well, let's transition
we've been
from
recording
that.
too.
I think I'm going to I think I'm going to put this on as an addendum at the end of the video for anybody who wants to stick around, because that's a good story.